All right, students, it's Mr. Rich. I hope you can hear me out there. We are going to do some prep for the AP Precalc exam. And let me pull my pen up here. Here we go. If you are here, you can put a comment into the chat. I should see it if you have any questions. I think what I'll start with is just doing a quick overview of the exam. Hey, Ethan, welcome. Hopefully you can hear me. Can you hear me okay out there? Let me know. I started a YouTube live stream last fall and got about 15 minutes into it and realized my mic was muted. Somebody finally texted me. Can you hear me out there, Ethan? Or anybody else? Okay, excellent. Well, a lot of this information I think you already know because you've been prepping. Most of you have been prepping in your classes for the exam, but the exam's 3 hours long and you're going to have 2 hours multiple choice and you'll have 1 hour devoted to free response. And your free response should be 4 questions. I hope that your teacher has told you about Blue Book, right? Blue Book is going to be the College Board app that they use to deliver the test in, which is the same app that you would be taking the SAT in. And the FRQ responses are not going to be entered into Blue Book as I understand it, but you will have a booklet that you will be using. But you will be reading the questions on the Blue Book app, but then providing your responses in your handwritten booklet. You will have Desmos, the online calculator, available to you during the calculator active portions of both multiple choice and free response. So what I want to do tonight is I want to cover FRQ questions. So I've got about 3 or 4 FRQs. I'm not sure how far we'll get. And then 2 weeks from tonight, I'm going to do another session at 7 o'clock, and we will cover some multiple choice questions. Real quick, some formulas that you need. These are some trig identities, right, that you're going to need to know. You don't need to know all these. There's way too many here, but I wanted to show you the ones that you need, right? You need your tangent and cotangent identities for the ratios right here. Hopefully, if you've been doing a lot of work in your class, these are already ingrained in your brain. And if you know the unit circle, those make total sense. These are your reciprocal identities. Got to know the Pythagorean identities. Those will definitely be used multiple times during the test. If you know this identity, these other 2 identities can be derived by dividing both sides of that first identity by either sine squared or cosine squared. The other formulas you need are the double angle identities. Make sure that you have those nailed down. Your cosine 2 theta has 3 options. And again, these 2 options on cosine 2 theta can be derived by knowing this one and using that sine cosine Pythagorean identity to substitute in. And that will give you those other 2 identities. You do not need to know the double angle for tangent. And then I think the only other 2 here really that you need are the sum and difference formulas for sine and cosine. So make sure you know those. All right, without any further delay, I want to get right into working some problems. And here we go. All right, so I've got Desmos pulled up if we need it. Let's see where I've got it here. There it is. Okay, so there's Desmos, and I've got a TI-84 if we need it. The first question here says, suppose you are riding a roller coaster. After all people have boarded at the boarding point, the coaster begins to travel along the rail, accelerates to reach the critical speed before the loop entrance, and completes the 2 loops in 20 seconds. Let t equal 0 represent the moment the coaster enters the first loop. All right, so we're entering in down here. Now it says during the 2 the height, your height in feet above the ground at any time t in seconds during the 2 loop ride is modeled by this cosine function. What is the period of 1 loop? So the first thing that you need to know about period is that the period of a sine and cosine is 2 pi divided by the coefficient that is in front of the independent variable there. So b happens to be pi over 5. So we are going to do 2 pi, and we will divide that by the pi over 5. Okay, so that's going to be 2 pi over 1 times 5 over pi. So that's going to be 10. Right now, one of the things you want to be aware of as you're doing these free response questions is you do want to lay out your work so the grader can see it. And if they are looking for formulas, right, they want to see that you completed this work. So you want to show this progression. Now, this over here is 10. Now, we know that this period by definition is in terms of the function, is a horizontal length of time it takes for there to be one cycle, right? And so this has to be, since our independent variable is time, then this has to be seconds. Now, it didn't ask, it does say what is the period. So I would say that it implies that you should be including your units of measure there to be 10 seconds. Look at question 2. What does the period represent? Well, the period represents how long it takes to go through one cycle. So when you look at this problem, it does complete 2 loops in 20 seconds. And t is 0 at the moment it enters the first loop. Okay, and it is a 2-loop ride. But what we would say is, then we would say it represents, right, our period. We could say our period represents the time to complete and it keeps 2 loops in 20 seconds. 2 loops in 20 seconds. So it's the time to complete one loop. So that function right there is actually just representing one of the loops. So it's the time to complete one loop of the ride. All right. Next. And your teacher has probably explained to you that, right, these FRQs are designed for you to be easy at the first, right? We want students who maybe are struggling, maybe are weaker students, to be able to show what they do know. And so we try to give some easy ones up front for you to earn some points and show what you know. And then they should typically get progressively harder as you move through that particular FRQ, because each FRQ is multiple parts, each one getting more challenging usually than the previous. This says, what is your maximum height based on the given equation? All right, so when we go take a look at our equation, what is going to be our maximum height? Well, the plus 40 is going to be our midline for the cosine. And so that presumably is going to be, right, the midline that passes right through the loop. So the center of the loop is going to be 40 feet, right, above the ride. This height is in feet, but the amplitude is 30. So the maximum height is going to be 70 feet. Okay. It doesn't say to explain or justify, so I am not going to explain or justify that answer. I'm going to give the answer of 70 feet. Now, I could maybe show where I got that calculation from. Maybe I want to say it's the absolute value of the negative 30, right, plus the 40 midline that gives me 70 feet. But again, it just wants the answer there. When do you reach the maximum height in the second loop based on the equation given? Right, so we want to know, when would we reach the maximum height? Well, let's go back and take a look at this equation, right? It's a negative 30 cosine. And we know that the period is 10 seconds. So let's write that down. Our period is 30 seconds. Now, one thing that we know about cosine and sine is that, right, the quarter period that it takes is an important quantity. So I'm going to divide that by 4, right? 30 divided by 4, 30 divided by 2 is 15. So it takes 7.5 seconds to get through 1/4 of a period, and 4 quarters obviously is going to be, was that what we had? 30, no, 10 seconds. Sorry, 10 seconds. Okay, so our period is 10 seconds. And so our quarter period is going to be 2.5 seconds. All right, now to reach the maximum height in the second loop. So that's going to mean that if we plot what this function would look like, let's make for ourselves a plot. We know that this thing is up here at 40 feet, is going to be our is going to be that midline at 40 feet, and the amplitude is 30. And so it's going as high as 70, and it's going as low as 10 feet off the ground. But notice that it does start, because it's a negative cosine function, it starts down here at the negative. Now, does it have a phase shift? It does not. Notice there is no phase shift here, which makes sense because we're starting at the minimum value at t equals 0. Because there's no plus or minus inside the argument of cosine, there is no phase shift. So it does start down here at the bottom, right? And so it is going to go like this and complete one loop. And then, so it's completed one period. So this is going to be 10 seconds after one period. Then it's going to go through the next quarter loop. It's going to get right here. So that's going to be the next 2.5 seconds, the next quarter period, 12.5. It will then reach its maximum in the second loop over here at another quarter period, or half of the next period, at 15 seconds. Notice it says, when do you reach the maximum height in the second loop based on the equation given? T equals 15 seconds. All right. And that's what I'm going to answer. And that's how I'm going to arrive at that answer. Next, let's go to part C. How high from the ground in feet are you when the coaster just entered the loop entrance? So that's easy enough, because we know that that's going to be 10 feet. We already figured out that our midline is 40 with an amplitude of 30. So when you go in, that height is going to be 10 feet. Roman numeral 2 for part C. Convert the given height equation into another trigonometric equation, g of t, using the sine function. All right, well, the difference between sine and cosine is going to be a phase shift, right? And so what I could do is this. I'm going to go back up here to, let's go back and take a look at this equation right here. So, and we started to make the graph right here. So what I would do, notice that this is where the bottom of this negative cosine is. So I want you to think about it this way, students. What I'm going to do is I'm going to take this point right here at the midline, and notice that this is a quarter of a period to go from here to here. So that's going to be at 2.5 seconds. Notice it's helpful for me to know the quarter period here, 2.5 seconds. So what I'm going to do is I'm going to cause this function to shift to the left by 2.5 seconds. And when I do that, that's going to give me a positive sine function right there. So the only thing that I'm going to do to this function is I'm going to put in here a t plus 2.5. And that is all that I have to do. And it'll change it into a sine function. Now, into another trig equation using the sine function. All right. Now, what I want to do then to write my g of t is that, and let's look at it kind of from an opposite standpoint here. If the function was here and it was a positive sine, look at it this way. If it was a positive sine function going like this, then I would have to push that to the right by 2.5 seconds to make it the actual function that it is. So here's what we're going to do. We are going to write this as a positive sine function. The amplitude is 30. It's going to be a sine function. We are going to use the same pi over 5 right here as the cosine function was. But now what we're going to do is we're going to shift this sine function over to the right by 2.5 seconds. And that's how we accomplish that. And then we put a plus 40 right there. That's how I know that this is an equivalent function to that, because if you were to consider that function, it's going to have the midline at 40, it's going to have the amplitude at 30, but instead of it starting here going on its way up, that start gets delayed out here to 2.5, and it goes like this, and then that other quarter period comes down like that. So this is going to be my answer. So you shift sine and cosine by 1/4 of a period to go from a sine to a cosine. All right, if you have any questions on that, feel free to post them. I should see, if you are watching on YouTube, I should see the message pull up on my end. All right, and this was, now that was calculator active, but it really didn't require us to use a calculator, and I would not recommend using a calculator on that problem. All right, these are very common questions here about manipulating and solving equations. So let's go to this. What you will see, you should see these directions, which talks about how it is that you're supposed to simplify questions that they give you on the exam. So be sure to read through this, and I'll come back and look at that once we get done with one of these problems here. They're just telling you here, this is probably the more important thing here. You're supposed to combine terms using algebraic methods and rules for exponents and logs. So they say that you should be combining that to be 5x. You should be rewriting that as 5 to the 5th, x to the 3rd. And that would be the natural log of 15, right? Because you could condense that into one logarithm. But first question on this one gives you two functions, one a log, one a trig function. And it wants us to rewrite h of x as a single logarithm with a coefficient of 1. So they want you to use the properties and the rules of logarithms. So when I look at this, these are separated by minus signs. And so I'm going to condense these for Roman numeral 1 into a single natural log. But when I condense, I do need to move any coefficients that are in the front. I need to move those into the exponent. So one of the properties of logarithms is those coefficients can be moved up into the exponent of the argument of the logarithm. I'm not moving the negative. I'm just moving the 2. I'm leaving the minus sign to be in front. So it's going to be this trinomial raised to the 2nd power. And now I'm going to write it as a single log. What goes in the numerator of this logarithm is going to be the x cubed plus 8, because it has a positive in the front of it. These two are going in the bottom as factors. So this is going to be x plus 2, and that'll be multiplied by x squared minus 2x plus 4 all squared. All right. And it says rewrite as a single logarithm with a coefficient of 1, meaning they want that to be a 1 right there. All right, now that would be fine, although they do say combine terms using algebraic methods and rules for exponents and logs were applicable. And they want me to be rewriting things in equivalent form. And I do realize that this could be simplified. So I am going to go ahead and simplify it. The top expression inside the argument of my logarithm is a sum of perfect cubes. Right? We expect you to remember from Algebra 2 how to factor sum and difference of cubes. If you've got sum or difference of perfect cubes, we are going to factor that into a binomial times a trinomial. So the cube root of x cubed is x. The cube root of 8 is 2. I will then, for my trinomial, square the cube root. That's going to give me x squared. This one's going to be a 4. I will then multiply them. That gives me 2x. And then if you remember, a lot of teachers will tell you in Algebra 2 to use SOAP as an acronym to remember what signs, positive or negative, go into your factored binomial and trinomials. This stands for same, opposite, always positive. Since it's a plus between the x cubed and 8, it's a same, opposite, always positive, like this. So, as it turns out, it looks like, well, it looks like this simplifies to a 1, that this is going to cancel, which makes me wonder, did they really want me to go that far? Because if I cancel that, I have the natural log of 1, because these divide out, and as it turns out, see, I almost made a mistake. I have a squared down here. So what happens is this x plus 2 cancels the x plus 2. This trinomial cancels one of them. This is to the 2 power. So my final answer in simplified form is the natural log of 1 over x squared minus 2x plus 4. That's going to be it. Now, this is different than AP Calc in that when it comes to free response questions in AP Calc, you are not under an obligation to be simplifying things. In fact, we tell students that take the AP Calc exam that if you have an answer that's a valid answer and you proceed to simplify it, either mathematically or algebraically, and you make a mistake, it's on you, and they very well could deduct points. So let me know if you have any questions as we move through this. Now, it wants me to simplify the k of x. It says, hint, no trig functions are involved in the simplified form. So let's try that. So this is cosine of 90 degrees minus x. Now, there is a trig identity for cosine and sine of 90 minus x. Now, you may or may not know what it is. All right. But remember this, that if you don't know what cosine 90 minus x is, there is something that you can do, because you should know the sum and difference formulas. So what I would do in this case is I would use the sum and difference formula here for cosine. I know that cosine 90 minus x is cosine of 90 times cosine of x plus sine of 90 sine of x. Remember that we changed the sign when we're doing the sine sum and difference. Over here, this is going to be sine of 90 degrees times cosine of x minus sine of x cosine of 90. Not doing anything yet with the cosecant x and secant x right here. But I do know that cosine of 90 degrees is 0. So that's going to knock that term out, and it's going to knock that term out. And I know that sine of 90 is 1. So what I end up with here, since sine of 90 is 1, I have sine of x and over cosecant of x. And there's a plus right here. Sine of 90 is 1, right? So that's going to be cosine x over secant x. Well, the next step then would be to replace the cosecant with its reciprocal, which is 1 over sine. So that makes this sine squared x. Replacing secant with 1 over cosine turns that into cosine squared x. And so my final answer is the number 1 right there. All right, any questions, students, on that? Next. Was that A? Yeah, okay. So we're still in the same FRQ. That was part A. Part B gives us 2 more functions. And here they want us to solve for m of x equals 1/2 for the values of x in the interval 0 to pi. Well, like typical College Board fashion, they don't give you the equation. They expect you to know that you're supposed to create the equation where you're going to set this function m of x equal to 1/2. So I will do that. In my test booklet, I will do cosine to the 4th x minus sine to the 4th x is going to be equal to 1/2. Like that. And I'm supposed to solve. Pay attention to the intervals here, right? They only want me to solve this for values between 0 and pi, and to be inclusive of both 0 and pi. So what I'm going to do is I'm going to use the difference of 2 squares. So this will be the square root of cosine to the 4th is cosine squared. So if I were to factor using the difference of 2 squares, it's going to be cosine squared x plus sine squared x times cosine squared x minus sine squared x. So that takes you back to your algebra at 2 days where they taught you special factoring, right? The difference of 2 perfect squares. Well, the identity cosine squared x plus sine squared x is 1. So that really is just 1 times this. But that's also the difference of 2 squares. So I think what I'll do is I will factor that. See, I think what they're doing here is they're trying to set you up for failure, which of course, that's always what they're trying to do, to make things harder than what they seem. If you did factor this into cosine x plus sine x, and then cosine x minus sine x equals 1/2, I'm not sure there's a pathway to solve that right there. So I don't think that's really the route that I want to go. I think they wanted me to maybe do that because that is something that we do in algebra oftentimes, is we have a higher power and we break it down and then we factor it again by difference of 2 squares. But no, I think what we're going to have to do here is we're going to have to take the Pythagorean identity, right? Sine squared x plus cosine squared x is equal to 1, and get rid of one of these, either sine or cosine, so that I could put it into an equation that has only one of the trig functions, not the mixture of both cosine and sine. So what I'll do, since the negative sine squared since the sine squared is the negative, I think I'll substitute for sine squared, right? So according to the Pythagorean identity here, sine squared is 1 minus cosine squared x. So then what I'll do is I will replace right here that sine squared with 1 minus cosine squared x in parentheses. Keep in mind, I'm bringing the 1/2 down. I still have the equals 1/2 over here. When I distribute that, that's going to give me cosine squared x minus 1 plus cosine squared x equals 1/2. I can combine those 2 cosine squares into 2 cosine squared x, like that. I will add the 1 to the other side. So that's going to give me cosine squared x. Somebody's coming home at my house because the dogs are going nuts. Ethan, you hear my dogs? So that'd be 1/2 plus 1, which would give me 3/2. Okay, it's World War III out there. And then divide by 2, we get cosine squared x is equal to 3/4, like that. Then what we'll do is we'll square root both sides. So we get cosine x is equal to the square root of 3 over 2, but we have to include both the positive and negative when we square root. So now it becomes a unit circle question. Where in the unit circle, at least on the interval from 0 to pi, that was where they asked us to restrict our answers to, that would be in the second quadrant, and I believe that's at 5 pi over 6. Oh, but it's plus or minus, right? So we'll include the 5 pi over 6 and the pi over 6, because it's either a positive root 3 over 2 or a negative root 3 over 2. Now, just some caution here, right? If you took the wrong turn and factored, and did, I think this is definitely cosine x minus sine x, cosine x plus sine x, and you get stuck and you're like, I don't know where to go from here, right? Don't dwell on it. Move to the next problem. Now, on this free response, there is a part C. Now, usually on AP Calc, AP Precalc, AP Stats, they want you to be able to move on to the next part. And usually they're not going to be linked to where you're out of luck on part 3 if you didn't get, or part C when you didn't get part B. If you get stuck, do not dwell on it and don't fret, right? You don't get flustered and don't get discouraged and down on yourself, because you are going to face some problems. Unless you're just like the top 0.5% of students, you're going to find 2 or 3 parts on the free response that you don't know how to do. You get stuck and you're going to feel like, I've never seen this before. Probably have seen the concept, but you probably haven't seen a problem like it. That's the whole idea. But it's okay, because you're not looking for 100% on this test. You don't even need 90%. Maybe, okay, you're shooting for 75 to 80% if you're trying to shoot for a 4 or a 5. Okay, so just don't waste time on a problem if you get stuck. Leave it, come back later if you have time. All right, next. If cosine theta is negative 8 over 17 and sine theta is greater than 0, compute cotangent of theta. There are 2 schools of thought on how to do this. What I prefer to do, students, is just to make a right triangle and not do it in the XY coordinate system. What I'm going to do is say, all right, there's my triangle, a right triangle, and there's theta. If cosine is 8 over 17, I'm going to ignore the negative for just a second, because I know right triangles, they have positive sides to them, right? But at any rate, in other words, the negative here has to do with the fact of what quadrant the angle is terminating in. So I'm not going to consider that just yet. I just know that the adjacent side would have been 8 units long, and the hypotenuse would be 17 units long. And so if I want to get cotangent of that angle, I know that cotangent of theta is going to be the adjacent side divided by the opposite side. So I need to get this side over here. So if you don't know what that side is, you can use the Pythagorean theorem in Desmos. Let's just grab a brand new blank new graph. There we go. I'm just going to take 17 squared, right, minus 8 squared. It's 225. Square root of that is 15. That's 15. So cotangent of theta is equal to 15 over 17. But I got to get the right sign, positive or negative, on my answer. This means, why did they tell me sine is positive? Well, because if sine is positive, yet cosine is negative, I know what quadrant this terminates in, right? This terminates in quadrant number 2. The angle theta is quadrant 2. So I'm going to say, right, because sine of theta is positive and cosine of theta is a negative value, therefore cotangent has to also be negative. If I'm in the second quadrant, cotangent and tangent are both negative. So my answer is negative 15 over 17. Now I could show you, what it would look like if you did this in the XY coordinate system, but I'm not going to bother. Now let's talk about Roman numeral 2. Evaluate the cosine of the arc sine of 3/4. Now, this is, I think we said this was a non-calculator. Yeah, okay. But we'll be able to do this, no problem. So, will we though? Yeah, I think we can. So, cosine of the arc sine of 3/4. So what I'm going to do here, students, I'm going to consider what arc sine of 3/4 is. Okay, arc sine of 3/4. They're saying what angle has a sine that is 3/4. Well, what that would mean then, I'm going to draw another right triangle. This one's in the first quadrant because arc sine is only either in the first or fourth quadrant, right? Arc sine returns angles for sine values of an angle. So if it is an arc sine of a positive, it's a first quadrant angle. So that would mean that the triangle had to have an opposite side of 3 and a hypotenuse of 4. So therefore, this one would be the square root of 16 minus 9. This has to be the square root of 7. All right, 4 squared minus 3 squared. 16 minus 9 is 7 square rooted. All right, so that would be the triangle for arc sine of 3/4. So what's the cosine of that angle? So the cosine of that particular angle has to then be root 7 over 4. All right, any questions, students? It's 7:41. We still have more time. Let's keep it going. See what else we got. Is this calculator? I don't remember. I think this was one of last year's questions. On the initial day of sales at T = 0 for a new video game, there were 40,000 units of the game sold that day. 91 days later at T = 91, there were 76,000 units of the game sold on that day. The number of units of the video game sold on a given day can be modeled by the function g given by this, where g of t is the number of units sold in thousands on day t since the initial day of sales. All right. It says use the given data to write two equations that could be used to find the values for constants a and b in the expression for g of t. And then Roman number 2, find the values for a and b as decimal approximations. Okay, so it definitely is a calculator active, or they wouldn't be asking me that for sure. All right, so what we're going to do for part 1 is write down our g of t. So we've got these missing coefficients, a and b, like this. So what I'm going to do then for my two equations is I'm going to use the 2 days of sales that they told me about. That when on day 0, then that would mean there were 40,000 units. Now be careful here. G of t is the number of units sold in thousands. So do not put 40,000 over here, right? I'm putting 40 because it's in thousands. So 40 is equal to, I don't know what A is, don't know what B is, but when they sold those 40,000 units, it was on day On the initial day, 0. So that would be the natural log of 1. That would be my equation. That's equation number 1. The second equation, okay, is going to be, on the other day, there were 76,000 units, and it was the natural log of 91. So that would be the natural log of 92. Okay. And so that's what we got. Yeah. Then find the values of A and B as decimal approximations. Well, what happens here, they want you to know one of the properties, we'll call it, of logs, is that whenever you take the logarithm of the number 1, the answer is 0. So on Roman numeral 2, I am going to solve here for A, because this would be 40 is equal to A plus B times 0, because the natural log of 1 is 0. If you're like, man, I don't remember. Well, that's okay. Come over here, to Desmos, not 1, natural log of 1, you see it's 0. And so that tells me that 40 is equal to the constant A. All right, so what I'm going to do then is I'm going to go ahead and stick that back into this second equation, because now I have 76 is equal to 40 plus B times the natural log of 92, like that. And now I'm solving this for B. I'm going to use algebra, and then I'm going to show you how you could use Desmos to do this. I'm going to subtract 40 on both sides. That's going to give me 36 is equal to B times the natural log of 92. And then to solve for B, I'm going to divide 36 by the natural log of 92. I'll come over here to Desmos and do 36 over the natural log of 92. And I need these as decimal approximations. So you always report your decimal answers to 3 decimal places. You can round or truncate. So this is 7.9961. Now, it didn't ask me to rewrite the equation. It wanted me to find A and B. I've done that. And that's all that I am obligated to do. Should I write the equation with the A and B? You know what? I don't see the harm in it. I am going to rewrite it as my final line. Would be 40 plus 7.961 multiplied by the natural log 961 times the natural log of t plus 1, like that. All right, that's it. Okay, now I'm going to show you something here on Desmos that you might find interesting or not. But if I wanted to solve this for B, one of the ways you use Desmos to solve equations graphically is to plot the left-hand side of an equation, y equals 76, and then I'm going to do y equals the right-hand side, which was 40 plus x times the natural log of 92. I'm using x instead of b. All right, so I graph the left and right-hand side of the equation, and then I look for the intersection point, scrolling out, and then we zoom in on this. Okay, the intersection point that you see there. Oh, I don't think you can see my Desmos. I forgot. Let me get myself out of the way here. There we go. So what I did in Desmos is I did put in here the left-hand side, y equals 76. The right-hand side, 40 plus x natural log of 92. So anytime you need to solve an equation, plotting both the left and right-hand side as separate equations, you can look at the intersection point, and that x-coordinate will be the solution. So there's my value of B, 7.961. But the algebra was so simple there was no need really to do that. I just wanted to show you that. All right, next, part B. use the given data to find the average rate of change of the number of units of the video game sold in thousands per day from t equals 0 to t equals 91. Express your answer as a decimal approximation. Show the computations that lead to your answer, that lead to your answer. So Roman numeral 1, they're asking me for average rate of change. So what I'm going to do is write down an average rate of change formula generically. It's a slope calculation. F of B minus F of A over B minus A. It's the change in the Y divided by the change in the X. It's a rise over run. Now for us then, I would say this, that the average rate of change from t equals 0 to t equals 91 is going to be by the following formula. I'm going to do G of 91 minus G of 0 all over 91 minus 0. That's how you do average rate of change between those two values. So then you're going to show the grader that you're plugging those values in. On day 91, it was 40,000 units. Sorry, at day 91, it was 76,000 units. And yep, and they want this in thousands per day, right? So 76 minus 40 over 91 minus 0. I will then, over in Desmos, actually do that calculation now. I'll do 76 minus 40, put that in parentheses, and then divide it by 91. And my answer there is 0.396. Okay, now what are the units of this? Well, these were thousands of video games. That was what this calculation was, that difference. And this is days, 91 days. So I could write this as 0.396 thousands per day, like that. Or alternatively, I could write this as 396 games or units, games, units per day, like that. Now they said like a decimal approximation. Well, yeah, so I would probably stick with the 0.396 thousands per day. All right, Roman numeral 2. Use the average rate of change found in question I or 1 to estimate the number of units of the video game sold in thousands on day t equals 50. Show the work that lead to your answer. So what are they talking about here? They're talking about making an estimate. So we are going to come up with an equation to estimate the number of games that are sold. And what we're going to do is use the point slope form of a linear function. Those of you that are moving on to AP Calc, you'll be using this quite a bit because you'll be coming up with equations of what we call tangent lines to functions. And point slope is how we do that. What we just calculated was the slope between day 0 and day 91 is 0.396. That's what I'm going to put in here for M. And then what I'm going to do is plug in either one of the 2 days for which we knew the games that were sold. I'm going to use the easier one. And on this FRQ, they would let you, there's 2 correct answers. You could use either of those days. I'm going to use the one that was t equals 0 and it was 40,000 units sold. So it's going to look like this. Y minus 40, right? What I'm plugging in there is 0, 40. That's my t. That is my games sold, G of t, 40. So y minus 40 is equal to 0.396 times x minus 0. And that gives me a line that would pass between the 2 points that I knew, day 0 and day 91. And there's the slope. Now, what I'm going to do is I'm going to move that minus 40 to the other side. That's 0.396 times x plus 40. And what that is that's an equation that I could use to estimate the number of games that are sold somewhere in that interval that that's what they wanted me to use it for, is to come up with this equation of a line so I could plug in some other value of t between 0 and 91 and get the estimate of the number of games sold. And the number they were talking about is day t equals 50. So then I'm going to say that g of 50 is approximately 0.396 times 50 plus 40. So I'm plugging in day 50 right there. I'll come over here and do 0.396 times 50 and then add plus 40 to that. And we get an answer of 59.8. Thousands of games sold is my estimate right there. So that's what they wanted us to do. Then there is a part 3. Let's see what that says. This says part 3, let A sub t represent the estimate of the number of units of the video game sold in thousands using the average rate of change found in 1. For A50, which I just found, it can be shown that A of 50 is less than G of 50. Explain why in general that value has to be less than that for all t where you're between 0 and 91. Okay. Okay, why does that have to be true? Let's see. So we've got a natural log function for g of t. Okay. And our estimate is lower. No, what is A50? No, okay, is actually, so they're saying that the estimate amount is going to be lower than the actual amount on day 50. Now, why would that be true? Good question. So it's a natural log function. And we know the general shape of natural log functions. But let's graph it. We're running out of time here, but I do want to graph that function that we came up with. 40 plus 7.961 times the natural log of x plus 1. Okay, so that is the log function that we came up with that estimates the number of video games, right? And there's the day 0 at 40 right there. And so we were making an estimate and we were doing, so what's happening here is we made a tangent line that went from here over to here. And so that tangent line is definitely going to be below the curve. And so let's see. Explain why in general that estimate is going to be lower than the actual amount for all t between 0 and 91. And let's see, you know what? I am not too sure about the justification for that, except from a graphical standpoint. But let's take a look at part C. I think what I'll do is I may post a video on that one there, giving that solution here on the YouTube channel. Part C. The makers of the video game reported that daily sales of the video game decreased each day after t equals 91. Explain why the error in the model G increases. Why the error in the model G increases after t equals 91. That the sales decreased. Okay. Well, I think the answer they're looking for here is that a logarithm function is always an increasing function, right? So it always has a positive slope. Now, the characteristic of logarithms are that the rate of change is decreasing over time. The slope is getting less and less, but yet the slope is still always going to be positive on a logarithm function. So the explanation here is that logarithm functions are always increasing when in the form for this equation. And then I would repeat that equation. So they're always increasing. And so if the sales begin to decrease after day 91, then the error of the model must get larger and larger over time. That's going to be my explanation on that. So I will take a look at those last two. And what I've been doing is about every day I've been posting a short YouTube video either on AP Precalc or SAT. So what you might want to do if you're interested is you can subscribe to my YouTube channel and get notified when one of those videos comes out. And I will promise this week that I will cover those last two questions there and give a better explanation on those. Also, if you've got any questions, let me know. You can post them here to this YouTube video, and I'll be sure to reply to that. That's going to be it for tonight, students. So come back on the 20th of April, same time, 7 p.m., and we will cover some multiple choice questions, okay? But thanks for coming in, and I will see you in a couple weeks. Have a great week, everybody, and study hard.